Good morning, good afternoon, and good evening to all of you joining us from different time zones. Thank you for taking the time to attend this conference presentation. Today, I'm delighted to present the findings of our recent research publication titled Cardiovascular Disease Prediction Using Ensemble Technique, a stacking approach to you all. This research is a culmination of our hard work and dedication, and I hope you find it as interesting as we did. Before we begin, let me give you a brief overview of the presentation. I will first discuss the background and objectives of the study, followed by the literature review, methodology, results, and conclusion. Let's begin the presentation. Cardiovascular diseases, short for CVDs, they are a group of disorders that affect the heart or blood arteries. They are the leading cause of death around the world every year. High blood pressure, excessive alcohol consumption, cholesterol are few examples of the most common risk factors of CVDs. With early detection of the disease, the chances of survival do increase. However, traditional methods of estimating the risk are based on the experience and knowledge of the doctor, which is highly error-prone and not always accurate. Additionally, manually obtaining insight from a large medical dataset is challenging and tedious. With the emergence of machine learning algorithms are trained to make accurate predictions from data given in a shorter time compared to manual methods. Unfortunately, single classifier algorithms are weaker compared to ensemble classifiers due to ensemble classifiers being able to combine multiple single classifiers and aggregating their outputs under a combination rule. Existing studies have employed single classifiers to make predictions. However, single classifiers may have drawbacks such as overfitting and bias. Therefore, this study proposes a stacking ensemble classifier which combines several single classifiers to produce an optimal predictive model. The objective of the study as follows: to perform exploratory data analysis on the risk factors of CVDs, to build CVD prediction models to predict the presence of CVDs, to evaluate the performance of the stacking ensemble classifier against the single classifiers. Based on the literature review conducted, it can be seen that the Cleveland dataset was the most frequently used. However, it only contains 303 instances, which may not be adequate to train and test machine learning model. In the current literature, the stacking ensemble method is rarely used ensemble technique to predict CVDs. Hence, this study aims to use stacking ensemble method to predict CVDs. We chose stacking ensemble method as stacking is the most effective when using low correlated Bayes models. As a result, the Bayes model's diversity helps achieve more robust and better predictive models. The table shown is a summary of the conducted literature review, outlining the used datasets, sampling methods, best performing classifiers, and metric used to evaluate those classifiers. The figure shown is the flowchart of the proposed methodology for this study. We used Framingham Heart Study dataset as it contains comprehensive set of features related to patient details such as demographic, behavioral, medical history, and current medical conditions of patients. The dataset was collected from 1948 to 1972, where each participant was examined 3 times for the outcome of the following events: angina, myocardial infarction, thrombotic infarction, or cerebral hemorrhage or death. The dataset contains 11,627 rows and 39 variables. We also have performed feature selection to only use variables that are most important for our target variable and reduce computational time and model complexity. The diagrams shown are a series of bar charts of gender and age groups and pie chart of diseases grouped by presence or absence of CVDs. Based on the findings of our exploratory data analysis, we found that the proportion of males with CVD was higher than females, even though females have a higher frequency. It could mean that males are more susceptible to CVDs compared to females. Our next finding shows that ages with highest ratio of presence or absence of CVDs are 65 years old and above, with almost half the seniors having CVD. Although adults are as many as seniors, they have the least frequency of CVDs. Age could be considered as a risk factor for CVDs. The count of positive diabetes is relatively low. It is notable that more than half of the diabetic patients have CVD, which means that diabetes might be a risk factor for CVDs. This study uses KNN imputer to deal with missing values. We employed K-highest score, also known as select K-best, method for feature selection. If you take a look at the pie chart shown, it shows that there is an imbalance in the dataset where the positive class, which is patients with CVD, is a minority. To deal with such imbalance, this study uses SMOTE. The study developed various single classifiers such as decision tree, KNN, logistic regression, SVM, naive Bayes, and multi-layer perceptron. Ensemble classifiers such as extreme gradient boosting, random forest, majority voting, and stacking. The data was split into training and test data, where 80% is used for training and 20% is used for testing. The classifiers are developed using 10-fold cross-validation. Hyperparameter tuning using research CV was conducted to maximize the performance of each developed model. The diagram on the right shows the base models and meta model of the best performing stack classifier after performing extensive combinations of different base models and meta models. We can observe that the heterogeneous models performed well when stacked together. The performance metrics used to evaluate the performance of the developed models were accuracy, precision, recall, and F1 score. The most important features identified by the feature selection process were systolic blood pressure, HDLC, LDLC, glucose, age, diabetes, and death. The table shows that the final performance measures achieved for each classifier using the Framingham Heart Study dataset. Based on the results achieved, F1 score was considered to be the deciding measurement in this study, as it has been designed to work well with imbalanced data. Indeed, the proposed stacking ensemble method has achieved the highest F1 score compared to all single and ensemble classifiers. This study also performed statistical hypothesis testing using 5x2 cross-validation tests, comparing the proposed ensemble classifier against the other classifiers developed in the study to solidify the performance difference observed. The null hypothesis states that the proposed and comparison models have equal performance. If the p-value is smaller than the alpha of 0.05, we reject the null hypothesis. The table shows that the proposed stacked ensemble performs significantly better than all the classifiers except soft majority voting. This could be due to the predictions made based on the probabilities of different classifiers rather than the mode. Anyways, the proposed stacked ensemble classifier outperforms the other ensemble classifiers. The table shows comparison between our proposed model and the best performing models from the literature that uses the same dataset as us, which is the Framingham Heart Study dataset. Although one of the studies achieved the highest F1 score, 89.52%, the study only used a quarter of the data, 255 rows, to evaluate the model. Additionally, the study has performed sampling to balance the target attribute and as a result, the number of observations reduced from 8,391 to 1,275, which could be considered as significant loss of information. Comparing our study to the rest of the literature, we have achieved consistent results in predicting the presence of CVDs with good F1 score. To conclude this presentation, this study proposed a stacked ensemble classifier to predict CVDs using the Framingham Heart Study dataset. The exploratory data analysis shows that the gender, age, and diabetes as the most important risk factors for CVDs. Data preprocessing tasks conducted were feature selection, sampling, and dealing with missing values and outliers. The results of our study showed that the proposed stacked ensemble classifier had the highest F1 score. The significant test indicates that the proposed model performs significantly better than most classifiers except for soft majority voting. The comparative analysis showed that the proposed model outperforms most related studies using the same dataset. These are the references cited within our presentation. Thank you very much for your time and attention.